YouTube videos. And what you can see here right in front of you is the Dragon with two astronauts on board SpaceX.
Dragon will take over.
Yeah, spacecraft, right before docking to the International Space Station, in short, ISS.
Right, well, as we're
And
just about 5.5 minutes to their arrival and quick pass through waypoint 0, let's jump over to Gary Jordan over at Mission Control Houston to check how everything's lining up with the teams in Houston for this approach and docking. Gary?
Thanks, Dan. Really good to see Dragon, Bob, and Doug inside 500 meters, so close to the International Space Station, just flying through all of the milestones we have to get towards docking towards the International Space Station. A lot of prep work went into this moment. Previously, we transitioned control of the station's attitude to Russian thrusters, also configured the station itself for the docking attitude. Chris Cassidy was just finishing up his midday meal. His next activity, just a little bit more than 20 minutes from now, will begin to set up for Dragon monitoring. He has a tool called the RPOP. We'll be able to display some of the telemetry data coming from Dragon through the C2V2. This is the common communication for visiting vehicles. It's established a link between the International Space Monitor from this tool, again, setting up in just about 20 minutes. Everything going according to plan from the International Space Station side of things, getting great views from Dragon of the International Space Station. Look at that, the lights reflecting from the outside of the International Space Station turned on. So Bob and Doug have a very clear view of the International Space Station. Should be entering into an orbital sunrise here shortly. From there, we'll take you through the next few maneuvers, again passing waypoint 1 and going right into that manual flight test. Again, everything here from Mission Control Houston, International Space Station configured for docking. Everything's go from our end. Back over to you in Hawthorne.
All right, thanks, Gary. We're jumping in now with Bob and Doug inside the Crew Dragon. Again, you're able to see what they're looking at on those displays there, and this a view from the Dragon spacecraft itself. You can see the International Space Station continuing to close in. Right now, they're only about 430 meters away. They're going to be quickly passing through waypoint 0 in the next 3 minutes, and they're going to continue their way up to waypoint number 1, which is going to be just about 220 meters out in front of the station itself.
Yeah, and Dragon has a number of relative navigation sensors, items that are used for guidance and control of the vehicle. So right now, Dragon's in a pointing mode that has those relative navigation sensors trained on the space station, with the attitude control system making minor adjustments as it needs to, if there's any roll correction or anything that it needs to perform. And Bob and Doug getting closer and closer to that manual flight test. They looked pretty comfy in those seats for that view right behind them.
Yeah, they are suited up, and again, they get suited up for anything we consider kind of the dynamic operations inside the spacecraft. So anytime that they're either in an approach and docking maneuver or an undocking maneuver, and then obviously at the very start and the very end of their missions, which are probably the most dynamic phases, that launch and ascent, and then that deorbit and splashdown when they come home and splash down in the Atlantic. We are just 420 meters away from the space station, less than a third of a mile. Should be just about a minute and a half until we're passing through waypoint 0, and then Dragon's going to begin a little over 20-minute, about the 25-minute trip up to the docking axis. So this will be waypoint 1. They'll be 220 meters directly in front of the station, and they'll be lined up perfectly with that international docking adapter at the very forward port of the Node 2 module, also known as Harmony, on the space station.
And there'll be a small attitude correction there. The navigation and prop specialists on our team will monitor that.
And Again, things a little bit dark right now. We should have sunrise in about 25 minutes. And so things will light up as we get closer to that manual flight test, and hopefully by the time we're there, we'll be right in front of the space station itself. We should get some good light on Dragon, and hopefully some views from the station looking straight out at the spacecraft using the cameras that are right next to that docking port on Node 2. And then Bob and Doug will once again take the controls using those touchscreens to maneuver Dragon. They'll do a number of different translational maneuvers. So physically moving the Dragon spacecraft in space. Oh, we're seeing some thruster firings there.
Very cool to see those Dracos firing. They actually use a hypergolic propellant, so it's monomethylhydrazine and nitrox, which very, very handy because you mix those two propellants together and they make fire, which is exactly what you want when you want a reliable engine when you're doing these proximity maneuvers. So nice to see those.
Dragon SpaceX on Big Loop, approach 0 has started and the trajectory has converged on waypoint 1. Expect arrival at waypoint 1 at 1322 UTC.
Dragon copies on the Big Loop, 13:22.
So those words from Anna there, confirming good convergence. So what that means is the trajectory of the spacecraft is now syncing up with where waypoint 0, waypoint 1 would be when both spacecraft are moving forward in time. So that means that Dragon will be right where it needs to be, and we're expecting Dragon to reach waypoint 1 about 25 minutes from now.
Yeah, and that still puts us about 16 minutes ahead of the original timeline. So we're expected to arrive at waypoint 1 at 13:22 UTC, or 6:22 a.m. over here on the West Coast in Hawthorne. And if we continue to track about 16 or so minutes early, we may get to that docking a little bit early as well. Again, we were tracking right around 7:30 a.m. Over here on the West Coast. So we may be more in the neighborhood of about the 7:15, but obviously that just depends on how all of the additional maneuvers go. But Dragon so far moving ahead of schedule in its flight to the International Space Station. We've moved past waypoint 0, so we're inside 400 meters right now, just under 370 meters away from the station. Already converged on its next stop is going to be waypoint 1. And once it gets there, again, the crew is going to jump in and command a hold before they move into their manual piloting test.
So, dear ladies and gentlemen, what you can see right in front of you is the docking process. Actually, before the docking process to the International Space Station from the Dragon Demo-2 crew spacecraft. It's now blinking and adjusting its position towards the ISS.
All right, it is
Let's
6 a.m. here
again.
in Hawthorne. If you're just
Please
now
enjoy.
tuning in, the Dragon spacecraft well in range of the International Space Station right now, just 350 meters away. We've stepped through all of our procedures, all of our burns, all of our maneuvers to get Dragon to this point since we launched just a little over 17.5 hours ago. Dragon was able to make all of its maneuvers to get it on the same orbital plane as the International Space Station, and we've already begun integrated operations between the teams here in Hawthorne and those out in Mission Control Houston, and now we're just really getting into some of the final steps before Dragon makes it to the space station.
Yeah, and on your screen right now we're in orbital night, so the Earth is blocking the sun, but you can see the lights from the Dragon spacecraft. That flashes a light that's right along the forward hatch. Right now, Dragon is in a relative pointing mode that's pointed directly at the space station and making its way towards waypoint 1, which is about 220 meters below the station. The International Space Station, when we're doing proximity operations, has a couple of imaginary gates. They're sort of three-dimensional shapes around the space station for vehicles that are approaching. Right now, we're moving towards a hold just outside of their spacesuits, monitoring the transition, and when they get to waypoint 1, they'll issue a hold to conduct a manual flight test on this test flight mission.
Yeah, this will be their second manual flight test, and really the second kind of key objective for them to really put Dragon through the ringers. This is a demonstration flight. This is that final test before we certify the SpaceX Dragon to operationally carry full crew complements to the International Space Station. They were able to complete their first flight test shortly after getting on orbit. That one, they focused on changing Dragon's attitude, using the Earth as a guide to put Dragon in a very specific orientation known as local vertical, local horizon, essentially putting it in an orientation the same as a plane flying over the surface of the Earth. So the attitude control of Dragon, just one part of, or really one half of controlling the spacecraft. Now they're going to be testing out the translational maneuvers. So once they command that hold, the first thing that they'll do is align Dragon very precisely with the actual docking axis, and then they'll step through and send a number of commands to the spacecraft through those touch screens, moving it across a couple of different axes. So again, translational means you're moving left, right, forward, backwards, up, down, and that's one half of really controlling the spacecraft, is you have all of these different axes to worry about, both translational and for attitude. So they'll step through those. Depending on how those go, we'll then be able to move in for the final approach.
Yeah, that's right. One thing to consider with a spacecraft is it is a three-dimensional body that's moving in space. So you not only have to control your X, Y, Z position, that up, down, left, right, forward, back motion, but you also have to control which direction you're pointing. So we've alluded to the sim online that starts you off in a skewed attitude. Anytime you're pointed in a different direction, then do those translations, you have extra motions that you need to cancel out in space.
Yeah, I remember the simulation too can show you how deceiving it can be to fly in space, because when you initially look at it and you load up, it almost looks like you're already pointing directly at the docking port, and I just need to go straight, when in fact you need to physically move the capsule down and left and roll it so you're completely lined up, and then change which direction you're pointing. It's just infinitely more complex than just getting in your car and doing a left, doing a right, going forward, backward. You're operating in all dimensions when you're flying in microgravity in a spacecraft. So Dragon doing that autonomously right now. The crew will step in to do some manual control, just to again prove out the Dragon systems for the crew to jump in should they have to. Looks like we're getting some thunderstorms actually on the Earth below. Let's see where they're flying over. We're still over the Pacific Ocean. We just flew over the island of Fiji in this orbital nighttime, about 264 statute miles over a restless planet Earth.
Beautiful to see those views of the planet. Even more beautiful when we had orbital daytime. Saw nighttime over Japan as we were flying over the Terminator.
Yeah, we're able to see a couple of city lights on the Earth's surface below. We're a little more than halfway through this orbital nighttime. We should be getting sunrise in about 15 minutes from now. And at that point, we will be just about arriving at waypoint 1. So we should be getting sunrise right as Dragon is arriving, just about 220 meters out in front of the space station.
Here's a cool view from the station camera. You can see Dragon approaching.
So,
We've
ladies
just got
and
those
gentlemen,
red and green lights on either side of the capsule. It gives folks looking at the capsule a sense of orientation of the vehicle.
what you can see here is an historic moment.
And here's a view
in
from
human space flight.
Dragon. Dragon's got a number of relative navigation sensors.
NASA astronauts from an American spacecraft will dock to the International Space Station in the short.
You can actually,
and this is
you
the
can see
screen
the solar
right
panels and actually the thermal radiators
from
there.
inside the capsule.
Here's a great view from
Two
a camera
astronauts,
behind
left, right,
Bob
looking
and
to
Doug.
the screens
Bob
and
in
checking
the
all
right-hand
the
seat in the pilot
parameters.
seat, Doug in the commander seat,
And this is
CDR
how
seat.
it looks from now
got
on
a
into the
display
future,
in front of them. That's the forward view.
which
It's
one
got
day
some
will
procedural
allow
information on the
very
left-hand
soon
side
actually
that's telling them criteria that they're looking for.
possibly
Anything off nominal, they could of course,
commercial
step in
flights
and issue a command
to the
if
ISS,
necessary.
and probably very
And
soon
on the,
also to
the
moon,
left-hand and right-hand
and then
screen
later
were actually
on.
their piloting controls.
Hopefully not that too
So
much
when-
later, to
When the
Mars.
vehicle is in an appropriate state to receive those
And
commands,
that
they
should
can
be
just hop in
accessible
and
for,
use those touch-sensitive gloves.
it should
issue
actually
commands to the
become
vehicle's attitude
normal.
control system.
Like if you travel with an airplane today, that you can fly to moon and to Mars, and very likely someday even beyond.
Have a little over 13 and a half minutes still in this maneuver.
So please enjoy.
It is really cool to get this look inside. And
This
again,
is how it
that
looks
screen
live,
in the middle,
live
you
view
can see
from
the
the
trajectory
Dragon
that Dragon is
capsule.
on. And if they were to just continue, it would eventually take them on a path away from the International Space Station. But at the very top of really their orbital path, right, have the vehicle essentially hover. These docking maneuvers in close proximity to the station. We have about 13 minutes to go. They're moving at less than half a tenth of a meter per second as they continue to close in.
There's another view from the space station looking back, and there's a brief moment there when we were looking at Doug's display where you could see that same view that we had of the International Space Station. So they have those views from the vehicle overlaid on their displays to give them some. Fingers crossed they won't have to do that today, though, and that the flight control system will operate as intended.
Yeah, we'll get the manual piloting demo, and then it'll be handed over to Dragon to do a nice, smooth operated, automated docking. Again, we've not been tracking any issues with the Dragon spacecraft on the whole flight uphill. Been moving through each of these burns a little bit ahead of schedule, running about 16 minutes or so ahead of the timeline as it was originally mapped out.
Yeah, very, very healthy vehicle, this test flight, very little. I'm sure Bob and Doug have a few things as well that they're getting used to. There's only so much a simulator can train you on. I think they had mentioned a little bit of that during the ascent portion. There are a few things that are a little different than what they expected. But just because when you're actually launching on a rocket, that's a different feeling than sitting in.
As they did give credit to the teams here at SpaceX, the actual piloting of the spacecraft went off exactly like their simulators. And so they're able to do all of that training here in Hawthorne, both in a cockpit simulator and in a full mock-up of the Dragon spacecraft itself, even able to get fully suited, plugged into the seats, go through all of the different systems that they had to get familiar with before they moved into their flight today.
Yeah, you and Jesse actually had a really cool opportunity to step in and see the training capsule. The team that I work on actually gets to help train the astronauts that are coming through, so I've had some cool opportunities to interface with the Crew 1 crew. They've already started their training for the Dragon vehicle.
Yeah, you get the really cool job. I get to come tag along every once in a while. But yeah, it was really exciting to literally sit in the seat where Bob and Doug were as they prepared for this mission. It was really exciting.
Ladies and gentlemen, you see the Dragon capsule.
Station at Houston on the big loop for Chris, crew monitoring.
From SpaceX to approach the ISS. This is a view from the ISS towards the
Chris, you can begin to monitor the approach per step 1 of 1.104 Crew Dragon approach and retreat monitoring.
And the phenomenal thing, if you want to call it that way, is that, yeah, this spacecraft from SpaceX will approach the ISS full autonomously. Please enjoy.
So heard some cool stuff over the loops there. Looks like Chris Cassidy aboard the station is getting ready to monitor. We'd sort of talked about this earlier, but during the Demonstration 1 mission, the crew aboard the International Space Station had issued commands to Dragon. That's a capability that they have. So.
Yeah, so with Chris Cassidy now monitoring, we're a little under 9 minutes away from that arrival at waypoint 1. Let's jump over to Gary real quick for a quick station update, and he can walk us through some of the systems that are going to be in play during this manual piloting test. Gary?
Thanks, Dan. Yes, we're monitoring the approach of Bob and Doug. Now position in front of the RPOP. This is the rendezvous software that he'll be using to watch some of the manual flight test. They will be communicating through the C2V2, Common Communication for Visiting Vehicle. You heard the call on the big loop. That was Joshua Kutrick here in Mission Control Houston, Capcom, talking with International Space Station Commander Chris Cassidy all over the big loop. That's an integrated communication loop with space to ground on station, Dragon to ground on Dragon, everybody hearing the same thing. Once we're in position of the manual flight test, C2V2 will transition to receive video as well. We should be getting some great video from Dragon all through the hardware that is on the International Space Station, integrated and linked with the Dragon. Now just inside 300 meters from station. I'll toss it back over to Hawthorne as we go through these next steps, heading towards waypoint 1.
Yes, what you
right on. Thanks for that
witness
update,
now
Gary.
Is a very historic moment for
As Gary said, we're inside
American
300
space
meters away from the space station. Should be getting
flight.
that arrival at waypoint 1 in just about
And,
6.5 minutes
course,
piloting test.
and you will see
Just
what
to
is coming
give you a long
in the next
look
few
at
months
everything.
and few
We
years.
were originally tracking
It will be
the docking
phenomenal.
Just a few seconds before 7:30
It will change
a.m.
how we
Pacific time.
travel,
We have been moving
how
well
we
ahead
work,
of the timeline, so we may only
and
be
how we
about an hour
communicate,
away from docking at this
and
point.
may
as
even
they're
much
moving,
more.
about 16 or 17 minutes ahead of schedule so
So
far with all of Dragon's maneuvers. We'll
let's
consider
listen
that
in.
initial contact and capture of the vehicle to be that initial docking. After that, though, there are a series of steps that have to take place with the Dragon vehicle, actually done in concert with the station itself, which will do a quick handover of its attitude control systems, and then the soft capture ring on the Dragon spacecraft will begin to retract, and then a series of latches or a series of indicators will tell the Dragon spacecraft when it's ready to start driving hooks, which will secure it very firmly to the international docking adapter on the very forward Node 2 port on the International Space Station. And then once we have docking complete, there will be a series of steps both for the crew on Dragon and for the crew on the International Space Station.
Yeah, that's right. Once docking is complete, the cavity in between the PMA node and Dragon, which we refer to as the vestibule, that is still a vacuum. So we'll do some steps there to bring air in from the International Space Station to pressurize that volume. There'll be a leak check on that volume to make sure that we truly have a good seal. Don't want to lose that precious life support to the vacuum of space. And then, of course, when we pressurize that volume, that area has been exposed to space for a pretty long period of time, and we're expanding a gas into it. So the temperatures will fall in there a little bit. So there'll be a period of time for a thermal hold to wait for temperatures to stabilize and to confirm that the pressure is good. So once all those things are good, then we can hopefully open the hatch, the forward hatch.
We do expect it'll take about an hour and a half or so typically before we start seeing hatches opened between the station and the Dragon spacecraft following a docking. And there are going to be two hatches. The first on the station side is the A-Pass hatch. That one will get open first, and then on the station side, before Bob and Doug are able to open up the Dragon hatch. A number of other things are taking place while we're waiting for the hatch opening to occur. Dragon, once it's docked to the space station, will be able to connect via an umbilical to transfer power from the International Space Station, so no longer needing to use its own solar arrays to power batteries and all the systems on board, be able to draw power.
Dragon SpaceX for Approach 1 on Big Loop. Approach 1 and the soft capture ring extension will begin shortly. Command a hold 20 seconds after beginning Approach 1 for the manual piloting demo.
Copy from the Big Loop. 20 seconds after Approach 1, we will command the hold.
Good copy.
And so real quick, what they're referring to there, in about 2.5 minutes, we'll be at waypoint 1, so about 220 meters out in front of the space station. And then, just like waypoint 0, the vehicle able to bypass waypoint 1 and continue on its approach to the space station. The crew is going to jump in 20 seconds after they hear that Approach 1 has started, command a hold, and then they're going to move into that second manual piloting demonstration on board Dragon. So we should see that all start to happen in just about 2 minutes. And thankfully, as promised, the sun starting to come up on both of our spacecraft.
Yeah, they also mentioned the soft capture system. So they'll do an extension of a ring with 3 pedal-like structures on it, approach for docking. Those will interface with the international docking adapter and give us a confirmation that we've made what's called soft capture. Now, at that point, the spacecraft may have some relative motion, so that system helps get rid of any of that relative motion before we go in for final closure of the hard capture hooks.
All right, so just a little under a minute to go now. Dragon just about right out in front of the International Space Station. Again, in less than a minute, it'll begin its Approach 1, and then our crew members inside of Dragon will command the vehicle to stop. It will hover, and then they will be able to begin that manual piloting demonstration.
Just about 240 meters away from the space station. We're pretty much lined up right in front of it, along what we've been calling the V-bar, and you may hear that on comms.
We do have a short communications blockage with the space station. We have pretty continuous coverage. We've had pretty continuous coverage getting views from the station cameras, which come down through our higher data rate, our KU band antenna. Sometimes It can actually get blocked by some of the station structure, whether it's solar arrays or other pieces of the station, depending on where the actual TDRS satellite that it's pointing at is located. And it looks like we do have that blockage for the next 5 minutes or so. And then once that clears up and we have a clear line of sight for that antenna, we'll get that video back from the International Space Station. So we're expecting that to come about 28 minutes after the hour, so in about 5 minutes from now.
Ground control teams still certainly have good data to both Dragon and the International Space Station, so they're still able to monitor what's happening, have good telemetry, so different sensors, the velocity of the vehicle, how the prop is doing, if any thrusters are firing, what commands are being sent.
Between those tracking and data relay satellites, and standing by for confirmation of that hold.
Station at Houston on the big loop for Chris monitoring. Station in preparation for Endeavour's manual piloting demo. You can monitor now per block Charlie in 1.104 Crew Dragon approach and retreat monitoring.
I'll be block Charlie.
Dragon SpaceX on big loop. Expect reconfiguration of the C2V2 return link shortly.
Copy.
All right, so we had confirmation the crew was able to send that hold. They're at right about 203 meters away from the space station right now, it looks like. Again, we should be getting the video views from the station itself back in just about 2 minutes from now. But yeah, Dragon holding just about 200, a little over 200 meters directly out in front. They're going to take a few moments to reconfigure C2V2, that common communication for visiting vehicles, to begin getting some higher data rates to get video from Dragon through the station as we begin to step into this near-field manual piloting demo. And just a reminder, Bob and Doug are going to be doing some translational maneuvers, so they're going to precisely align the Dragon with the docking axis, so lining it up directly in the squared up, down, left, right. Just another test of the manual control function on board the Dragon spacecraft, and then once they're Dragon. So before we start that, we do need to wait until we get that high data rate communication with the station locked back up. Again, should be just about another minute or so until that's in place.
And hopefully when we get that high data rate communication back, we'll also get some views into the cabin behind Bob and Doug. We got a few cool views of that earlier as they were getting closer and closer to station. So if you're just joining us.
Station Houston on the big loop for Chris. Work.
Ladies and gentlemen, what you can see is that the Dragon spacecraft is now 200 meters from the International Space Station away. As you can see on the right hand side on the top, almost in the middle. And yeah, this is...
So as I was mentioning earlier, if you're just now joining us, Dragon is now just
some
220
kind of exciting
meters
moment.
in front of the space station.
Somehow, yeah.
The astronauts aboard, Bob Behnken and Doug Hurley, have commanded a manual hold.
And there we have
to perform a manual piloting test.
Spacecraft.
There is a very nice shot of the Dragon
This is
vehicle
live
from cameras aboard the space station. You just saw the one of the Draco thrusters there firing.
The thrusters.
Just to keep it in that hold attitude.
Here we go again right to hold the line in its position. We're actually establishing
we have two cameras on the very forward port of Node 2,
right
so
alignment to
right where
C2V2 link reconfiguration is complete. The soft capture ring extension is also complete.
So we're going for the docking process soon.
On the big loop.
Please enjoy.
Good ring extension and C2V2 reconfig.
And just to say, by the way, that there are two NASA astronauts inside that spacecraft.
So those comms on the big loop, the core, the crew operations and resources link. Again, it's common communications for visiting vehicles.
And we will see.
We actually heard a little bit earlier
them
as well.
Soon again.
Comms to Chris Cassidy to monitor this manual piloting test.
The NASA astronauts inside that
Dragon
spacecraft.
SpaceX on Big Loop, you are go to execute the proximity manual flight test per procedure 4.041, and I have the target fuel levels when you are ready to copy.
We are go for 4.041, and we're ready to copy the fuel constraints.
Your 1/3 fuel usage will be 60.9, 2/3 58.9, and terminate 57.9.
We copy 60.
All right, so they're going to start maneuvering Dragon again, making some translational maneuvers. We did get some insight that it looks like they're a little bit to the left of the docking axis right now, and so we should expect them to move directly into the center line as one of their first maneuvers. That's going to be their very first maneuver. And then they have a strict list of choreographed steps just to test out moving on the other axes. And we heard the core Anna Menon calling up the expected fuel usage inside Dragon. They're going to be keeping a close eye on that just to make sure they're not overusing the propellant in this flight test, making sure we still have good margins for all of the approach maneuvers, and then obviously for everything at the end of the mission itself.
Yeah, and the thrusters that we're using here.
Dragon, on the big loop, we are commencing with docking axis capture.
We are following along with you.
So the
First part of this maneuver is just to really line impulse commands being sent to those Draco thrusters. Again, as Shiva was saying, there's the 12 around the lower part of the Dragon capsule that they're going to be using. We're seeing small bursts now.
Yeah, and they actually have a couple of precision modes where they can put in sort of coarse and fine inputs into the vehicle. That's all stuff that they can control off of those touchscreen displays to get the right amount of impulsive thrust into the vehicle. That's the nose cone on the top of your screen. So Bob and Doug would be sitting sort of underneath that nose cone and see the pressurized portion of the capsule, and their seats look up into the displays and also would look towards the side hatch, which is currently sealed underneath on the opposite side of where that nose cone is. Very cool to see those thruster plumes.
Yeah, the Kronos emission control Houston actually opened up the iris a little bit on that camera on the space station so we could see these plumes.
Yes, ladies and gentlemen, this is how it works today, and it will dock soon, and this is coming live directly while they're flying about 27,000 plus kilometers per hour. Aligning process and docking process. Please enjoy.
SpaceX Dragon, we've completed the docking axis capture maneuver. We're going to move on to the YZ translation.
Copy, we're with you.
All right, sounds like they've got themselves lined up exactly on the docking axis, so directly in front of that international docking adapter on Node 2. Now they're going to begin some lateral and axial maneuvers. So again, just putting Dragon now off the docking axis and to just continue these translational maneuvers. So at this point, we should see them head up to the right and up from this view as they're just making very small adjustments in the Dragon's positioning in front of the space station right now. Yeah, in the data, it looks like we're seeing the 6 thrusters essentially on the bottom of the is a very slow drift upward right now.
Yeah, it looks like they're going about 0.1 meters a second, if I'm looking at this data correctly. So very slow and steady. And they will probably do a quick correction to stop that upward movement. It's a little surreal seeing Dragon so close to the space station. You know, less than 18 hours ago, I was on the pad at
by humans for the second time already in this mission.
So I want to see that
and
it will
I
dock
would just be too excited. I don't know how
see.
Bob and Doug keep this so perfect. In aircraft, both test pilots.
Yeah, both came from military test pilot backgrounds. Bob Behnken, the Air Force Doug Hurley, a Marine Corps aviator.
And then I believe Naval Test Pilot School, so. A little bit overexposed there, but you can still see the thrusters firing.
You were at a normal exposure, so not able to see those jets into the darkness of space. But when we do overexpose a little bit, you're able to see those thruster plumes coming out of the Dragon spacecraft.
Yeah, it's yeah, and looking at the data now, it looks like we have zeroed out that that radial velocity delta. So Bob and Doug cleared out that small translation test that they did. We may get a radio call down here that they've completed the Y direction testing. Now, I know we've mentioned this a few times, but it looks like the spacecraft are totally still right now, and that's partially true. They're still relative to each other. But right now, both the space station and Dragon are going around the world, what is it, about once every 90-ish minutes?
Yep.
Or less?
Once every 90 minutes, seeing 16 sunrises and sunsets every single day. And while our view right now,
translation, moving on to the Y.
We copy, we're with you.
A copy. So I was a little bit mistaken. They just finished up the Z direction, doing the Y next.
Dragon SpaceX on Big Loop, you have used approximately 1/3 of your prop test budget.
And Dragon copies 1/3 of the prop test budget.
So the Corps letting the crew know how much prop they've worked through. Still have 2/3 of their budget left to do test maneuvers. And of course, any bit of propellant that they're using is just a little bit less margin if they needed to use it for something else. But good way to exercise the system, see that manual piloting works as intended, and I'm sure for them to have a chance to provide some feedback on how manual piloting actually felt in space and how the control felt.
yeah, a big part of their job for this mission is really to not only put the vehicle through its paces, but to take a lot of detailed notes and mental notes that they're going to be passing along to any future crew members flying on board Crew Dragon. As we've talked about, the simulators have been a pretty good guide for how the actual manual piloting goes, but things like the ascent up to orbit were quite a bit different from what they expected. And so they're just taking all of that in, internalizing it, and a big part of their job once they come home is to pass 3 NASA astronauts, Victor Glover, Mike Hopkins, and Shannon Walker, and a Japanese astronaut, Soichi Noguchi. We'll be aiming to do that flight a little bit later this year. So going through the paces right now, looking at our data, I think I made the same mistake you did. Small shifts. They're continuing to use up a little bit of their prop budget. We heard they're already a little past 1/3.
Yeah, it's actually something interesting about both aircraft and rockets. When you consider the coordinate system, what we refer to as the x-axis is usually the one that goes through the nose. So in the case of Falcon 9 and Dragon sitting on top of each other, the x-axis would have been pointing through the nose cone going up. Can be a little bit counterintuitive. And actually in aircraft, the z-axis usually points down, depending on whether you use European or American coordinate systems and the type of aircraft you're working on.
The movement of the aircraft, ladies and gentlemen, as you can see, the thrusters are firing.
For both space station and Dragon to be on the same coordinate system as they do this eventually as they step into the approach maneuvers here towards waypoint 2.
So
Dragon will be using its relative navigation when we get to that after this manual piloting test.
So manually piloting test or like a maneuver test they undergo.
We should be getting to that shortly. This manual piloting test was
steering manual
with all of Dragon's maneuvers. We could be looking at a docking only about 25 or 30 minutes from now. So once they're done with this manual flight test, they'll turn control back over to Dragon's flight computers, and they'll resume their approach, which had actually already started automatically before the crew issued a hold command to the vehicle. And then they'll press in to arrive at waypoint number 2, at which point the teams will do a final go, no-go for docking. They'll depart that 20-meter hold point, and it should be just about 5 minutes following that departure until we get contact and captured.
So what will happen after
the crew
this?
right now are seated in Dragon in the pilot and commander's seat. Both of them are suited for what are relatively dynamic maneuvers. And they'll continue to be suited until we have confirmation of good hard capture on the space station.
We'll give the control to the onboard
Hopefully secretly
computer.
A little bit giddy to be piloting a spacecraft.
And it will.
I mean, before they had launched, Bob Behnken had referred to this mission as every astronaut's dream. Pilot backgrounds.
It will work.
Testing out a new spacecraft
it should work
has to
perfectly.
be as good as it gets. But they're still stepping through this manual piloting.
So let's see.
We should have just a few more
I like
minutes
to see it
until
automatically
they're
docking.
done with this y-axis translation. And then they'll be able to turn command back over to Dragon, which will return itself to the docking axis and then begin that approach into waypoint 2.
Yeah, and as a look ahead, so when we do transition into that approach, Dragon will autonomously go towards waypoint 2, which is just 20 meters away from the forward international docking adapter on node 2. And it'll hold there. That'll give the ground team some time, both in Houston and here in Hawthorne, to do a go, no-go poll, make sure that the vehicle still looks healthy, make sure that everyone on board the space station and of course on board Dragon.
SpaceX Dragon, we've completed with the translation maneuvers. We're going to pick up with the closure maneuver.
We copy. We're following along with you.
All right, sounds like they're done with their translations. They're going to start moving it back to the docking axis, put us right back on the center line, and then we're going to resume that approach into station.
And that will be completely autonomous. I like that. So let's see. Please enjoy. Short introduction here to what you see right in front of you. You see the Dragon spacecraft, Demo-2.
Dragon SpaceX, you have used 2/3 of your prop test budget.
Craft is from SpaceX, which is carrying 2 NASA astronauts, and will dock soon to the ISS, the International Space Station. As you can see, it will be, that's what it's intended to do. The spacecraft should completely autonomously dock into the ISS. Manual control. Used 2/3 of the propellants for the thrusters to make that manual test. Autonomous docking. And yeah, this sets a new milestone in American spaceflight, and of course for actually the whole world, and will set a new standard in terms of how we access space. And in the future we will have commercial to Mars, and eventually, what I think so, someday beyond. So May the 31st, 2020, it's a Sunday. This sets a new milestone in spaceflight. You can see the ISS on the left side of your screen, and actually right now you can see more screen. This is, they're looking at 2 or respectively 3 screens with all the data, and yeah, the spacecraft will actually, the onboard computer right away.
We'll move on to 4.041, section 4.
Very soon.
Flight test has been completed.
And
We're
even much more
standing
to come.
by for them to now resume approach 1. So to move in from that waypoint 1, we're already inside of the keep out sphere at this point. Dragon's holding just 176 meters from the space station, and pretty soon they're going to be approaching.
Thanks, Dragon. That completes the manual piloting demonstration. I only had to twist Doug's arm for 2 or 3 minutes to get him to allow me to deactivate the piloting controls.
We copy. Excellent. Thank you. And with that, we ask that you, from the display used for manual piloting, please go to audio settings and adjust a gain setting for seat 1 or 4. And in addition, we would appreciate any handling qualities evaluation of the proximity piloting possible.
We've completed the gain setting adjustment for seat 1, and I'll turn it over to Doug for the handling quality quick look. SpaceX Dragon on the big loop for the handling qualities. It flew just about like the sim, so my congratulations to the folks in Hawthorne. It flew really well, very crisp. It was a little sloppier and wide, just like we saw in the sim, but all the other axes, as well as closure and opening, were all just as per.
Excellent to hear. Thank you.
Sort of how the design process works. You know, Bob and Doug have had lots of opportunities to test this out and sim it and give their feedback. And pretty cool to hear that their sim experience was very similar to what they saw actually on orbit. Just, I think you said 170 meters away from station right now?
Yeah, we're just 176, and I for the real thing. So the second manual piloting test in the books, Bob and Doug putting Dragon through its paces. Now we're time to put it all to where we get to our endpoint. We're ready to get Dragon docked to the International Space Station.
Dragon SpaceX on Big Loop. The ground will be resuming approach shortly. We do plan to hold briefly at waypoint 2, so reminder that crew visors down are not required until the ground is preparing to command the final approach.
Thanks, Dragon. We copy. We'll hold at waypoint 2 for a pause, and then we'll get our visors then once you command.
We copy.
And station, it's Houston on the big loop. As you've heard, Endeavour is resuming its approach to...
Copy, step 2 will work.
Pretty cool view of the International Space Station from Dragon. This would actually be overlaid, or rather their controls would be overlaid on the displays on top of this view. And we got to see some pretty cool views from behind. Actually, there's a view right there. You can see the station on their displays. Visors up, Doug in the left seat, Bob in the right seat.
So at this moment, Dragon is going to be resuming the approach. As we heard them informing the crew, they're going to have that one final hold when they're just 20 meters away. That's going to be at waypoint 2. We're expecting it to be a brief hold while the teams all tag up and do a final go to move in for docking. Getting a great look at the space station itself. The docking port is right in the center of our screen. You can see another spacecraft currently docked to the space station, the Japanese HTV spacecraft currently docked to the Earth-facing port, one of those common berthing mechanisms also on Node 2. So Dragon will be the second vehicle to be docked to the Harmony module once it makes its final approach. And it's moving in right now. Again, just to give you an idea of how quickly they're moving, they're going at about 0.3 of an exponentially. We just passed 140 meters away. We'll get our live video comm back with the space station momentarily. As soon as we do, we'll bring you back up there. But for now, Bob and Doug continuing to fly in. They're just 135 meters away.
Station on the big loop in step 2, review of steps 3 and 4 is complete. Crew on the International Space Station is ready for docking.
Station Houston on the big loop, we copy. The review of 3 and 4 complete. International Space Station ready, thank you.
Expedition 63 Commander Chris Cassidy giving the report. Station is ready for docking.
Yeah, and you can see the trajectory of the spacecraft. There are small corrections that are happening. So as we get closer and closer to station, we're trying to stay within those 2 corridors, which are shown coming out of the docking port that we're going towards. That little dot, I think, was the 20-meter hold point. So that's where we expect there to be the spacecraft holding with a set of what we call flight rules. So those are technical constraints, items that we look for, that if any of those criteria were violated, then we have a rule that we've predetermined, gives us guidance to say whether we could approach or not. So far, our vehicle has been very healthy, but technical ground teams will all do their due diligence to make sure that it's still safe to approach.
At this moment, that approach is continuing, still moving in at about 0.3 of a meter per second. Dragon's coming up on just 100 meters away from the space station.
So the very top there is the nose cone on the spacecraft, where we've got a cool view. Left side of your screen is the International Space Station. Right side of your screen is Dragon.
Just do a final check, and then they'll give Dragon the go. We're expecting it to be pretty brief. We should get to that hold point in just about 4 minutes, moving at our current pace.
I think you can see a meatball and American flag on that on the spacecraft. The NASA logo, of course, referred to as the meatball. I think there was some spirited discussion about the meatball versus the worm during ascent. And you can see those logos. That structure on the fairing structure is actually what the Super Dracos are housed in. Of course, all of those are deactivated now. Sealing surface, those 4 circular those 4 circular slots right underneath the nose cone within that red ring are the forward bulkhead Dracos. That's what we were using while we were conducting attitude corrections with the service section Dracos. And you can see the service section actually pretty clearly here too. And the bottom side, the white portion, is actually a thermal radiator that's used to keep the spacecraft nice and cool. Of course, the avionics and the cabin, making sure that Bob and Doug are comfortable inside.
It looks like we're getting a shadow cast. We are just 60 meters away, continuing to close in, just about 40 meters to go until we're at that hold point. Should get there in just over 2 minutes. Meanwhile, teams in Hawthorne and in Houston doing their internal go, no go for docking. They're going to get all the teams polled. Once everyone's go, we'll be able to give Dragon the final go ahead for the vehicle to autonomously fly in and dock with the International Space Station. Should be coming up on waypoint 2 arrival in just about 1 minute, 45 seconds. At this point, it'll be 20 meters away from that docking port. The International.
Right around the center, you can see the forward hatch. It's got a window in it. You can see a couple of handles, and there's some features that look sort of bronze-ish. Those are the pedals that we were talking about earlier as part of the soft capture system. So pretty wild too to see. We're so close that we're getting shadows from the station on Dragon. Wow.
And we're getting these views of Dragon's approach from 2 cameras that are right next to that docking adapter. And the movement's a little jarring at times. These cameras are being commanded by a person at the Cronus console in Mission Control Houston, and they send some very basic function commands to the camera, which it then executes automatically. And so they're continuing to follow Dragon in, so we do thank them for their diligence to give us these views of this historic moment as we are just less than 30 meters away from docking.
Right above the NASA meatball logo, you can see 3 of the service section Draco thrusters.
That's right, 12 in all. So the 4 of those clusters spread around the vehicle, used for a lot of the attitude control and any small translational maneuvers like we just watched Bob and Doug execute with their second manual flight test.
Yeah, and actually oriented in a way too where if you were to lose some of those thrusters, you still have redundancy and control in those axes. That's part of the reason why they're sort of at the angles that they are.
All right, so we should be getting to waypoint 2 right now. So it looks like
resume shortly. As a reminder, ensure your visors are closed prior to Dragon's departure from the waypoint. And once Dragon is inside the crew hands-off point, retreat and breakout are not permitted. And for your awareness, we have sunset in a little less than 8.5 minutes.
So Doug on the spacecraft confirming their go for docking. They're going to put down their visors. Got some instructions there about the crew hands-off point that we had talked about earlier. That's a point where we don't want the crew issuing any commands to the vehicle. It's about just about 2 meters away from the docking adapter. I believe the number is about 1.7 meters.
Station Houston on the big loop. Houston and station are now go for docking. Chris, you can monitor per steps 3 and 4. 3 and 4 in 1.104 Crew Dragon approach and retreat monitoring.
Copy steps 3 and 4.
So, ladies and gentlemen,
their visors down, we should see
go for a docking.
Final approach resume.
Have a look. How does that look?
From approach 2.
Copy inbound.
Mission copy.
And we're going to be racing that sunset. The approach has resumed. Dragon closing in. We're inside 20 meters. And yeah, that crew hands-off point should come up in about 3 minutes or so. Right before we get that final docking, it comes about 20 seconds prior, or just about 2 meters away from the station still. And that's just the crew not issuing any abort commands. At that point, it would be too late, and so any aborts would be executed automatically by Dragon itself. Point.
You can see the service section Draco is just doing all these very small, minor attitude corrections. Really, the autonomous docking system at work, making sure that the vestibule and the soft capture system is lined up with IDA2. It's the International Docking Adapter.
And ladies and gentlemen,
you can see much more clearly there the hinge mechanism for the nose cone.
This is completely autonomous.
Black circles are the forward bulkhead Dracos, not to be used at this time. And then, of course, the pedals of the soft capture system.
Dragon on the big loop.
Completely autonomous.
We cannot make out the docking target, but we do see the outline.
We copy and concur, 10 meters.
Right, we're less than 10 meters away. Again, we're closing at that rate of less than 1/10 of a meter per second. We should be just about 1 minute 45 seconds away from docking.
There is a center line camera right in that middle, so that you can. So that is what the autonomous docking system is using to line up with sort of a crosshatch, cross-tar meeting adapter.
We are just 5 meters away. Again, we're racing that sunset. This Dragon continues to close, 4 meters to go.
Those shadows of the space station on the vehicle. Yeah, you can actually see
2 meters. We are inside the hands-off point, the chop, the crew hands-off point, 1 meter to go. Soft capture complete.
Dragon in space. Soft capture confirmed. Stand by for retraction and docking.
And we just heard it, soft capture. We have docking. That coming at 7:16 a.m. Pacific time.
A little bit of motion there of Dragon. That was that relative motion that the soft capture system is damping out. Once that motion is clear, then the soft capture system will be retracted, and Dragon will go for hard capture.
Again, if just now tuning in, that soft capture, that docking coming 7:16 a.m. Pacific, 10:16 a.m. over on the East Coast. Dragon and the International Space Station were flying 262 statute miles right over.
On board.
Those are what will really create that pressure-tight seal between the Dragon spacecraft and the International Space Station. So once soft capture is complete, and I believe we'll get that call from our core here, Anna, then we'll get confirmation of hard capture, and the crew, of course, aboard have this information on their displays, so they'll also see indication of hard capture.
Words from everybody, a pretty monumental moment. I mean, for Doug Hurley, he's returning to where he last docked almost 9 years ago on the very last space shuttle mission, now commanding the very first commercial spacecraft to deliver astronauts to the International Space Station.
That's got to be cool for them. It's got to be really cool for their families, too, watching this.
Looks like we have another quick handover. We'll get that video back shortly. We're about 75% complete already with that retraction. Once that retraction is completed, we'll keep an eye out for the 12 ready to hook indicators.
Confirming that the soft capture system is deployed correctly and is fully retracted. And then once the soft capture system is fully retracted, that'll set up the vehicle to put in the hard capture pins. There's 12 of those around the docking ring, and that's what creates that airtight seal between the Dragon spacecraft and the International Space Station. The volume between, which we refer to as the vestibule, is currently not pressurized. Of course, it was just exposed to the vacuum of space until literally minutes ago, about 4 minutes ago. So just waiting for the vehicle to get that.
Dragon SpaceX, ring retraction complete. Docking sequence is holding for MCS reconfiguration.
All right, so we see those ready to hook indicators are lighting up green. So we should be just about to step into those 12 hooks beginning to engage to get that secure mate between Dragon and the International Docking Adapter on the space station.
Wow, right now those two vehicles are flying together. They are attached to each other.
It's been just under 19 hours since we lifted off. We're actually at about 18 hours, 58 minutes, and 42 seconds. So we promised about a 19-hour ride up to station, and we made it just a few minutes before that. They were able to dock a few minutes ahead of schedule. We were tracking them to still take about another 10 minutes, but able to step through all of their burns about 16 minutes ahead of schedule and get us to where we are now. If you missed it just a few moments ago, that initial docking coming at 7:16 a.m. Pacific, 10:16 a.m. over on the east coast of the United States, and they were 262 statute miles flying together over the northern border of China and Mongolia. So really exciting. We're just waiting for this docking complete to be confirmed. We'll expecting to hear some words, obviously, from the crew on board and all the excited teams down here. We're just waiting for this moment. And then it's time to start getting Dragon integrated into the station. There will be an umbilical that will get mated, and that'll allow Dragon to flow data and power into the station systems, and then it'll be over to the crew.
Houston on the big loop.
So the motion control system onboard station now back under those control moment gyros, so handed over from the Russian thrusters, and Dragon now given the go to drive those hooks. We have to do that changeover of attitude control before we drive those hooks, as the Russian thrusters a little bit more dynamic in their control of attitude, and if you had a thruster firing while you were starting to drive those hooks, that could miss a line. So going over to the smoother control moment gyros on the U.S. side, now controlling the attitude on board the station, and those hooks, those 12 hooks on Dragon, about to start driving.
Right now, Dragon and ISS attached, just flying off the east coast of China, just underneath Japan. Attached to each other. We recently passed over to the orbital night, so we're on the currently the dark side of the world. And actually, we're lucky enough to see soft capture happen just as we were crossing over the Terminator line.
And if you're wondering what you're looking at, this is one of the cameras on the very outboard part of Dragon.
Yeah, it's dark because they are in the shadow.
Horizontal to the ground. So the hatch part is right where that green light pretty much is. You can see the nose cone still illuminated above it, and it is currently attached to an international docking adapter on the International Space Station.
And inside that capsule are Bob Behnken and Doug Hurley, first astronauts to fly on a privately developed vehicle up to the International Space Station. Both test pilots got to do some fun tests today. Have a few more steps before they can actually get aboard and ingress to the International Space Station. And that's what we heard over the big loop. transition, which allows us to then proceed with hard capture.
Hard capture, a historic moment.
And we're seeing the first
Say
set of
what
hooks,
you want
so
to
the
say.
first 6 out of the
This
12
is a historic
are now
moment
closed. 6
in
more to
American
go.
space flight. And
there are
actually for
12
the
of those
world,
along the ring.
somehow, you know? Mm-hmm.
And that helps us ensure that we have an airtight seal. It is vacuum around them right now, so we want to make sure we're keeping all of that valuable life support in the vehicle. Now the combined ISS Dragon vehicle.
Ladies and gentlemen, as you can see,
Meanwhile,
two
inside the
NASA
capsule, Bob and
astronauts
Doug
are
also
still
standing by
in the spacecraft,
for this
watching
hard
on the
capture
screens
to
that everything
complete.
goes
And once we
smoothly.
have that dock, get out of their suits, and then they'll have some activities on the Dragon side to prepare for the hatch opening. Chris Cassidy will mainly be working on the station side to pressurize the vestibule. So as Shiv has talked about, the space between the Dragon capsule and the space station was exposed to vacuum, and even after this tight seal has occurred, we'll still be at vacuum inside. So we'll actually open up a valve to supply air from the station side into that space between the Dragon and station hatchways, and they'll get it up to the same ambient pressure that we'll have inside of Dragon and
I like
on
that.
the station itself.
Look at this. You have
they'll wait
good
for
screens
it to
with all the
thermally
data in
balance
front
out,
of you.
Make sure we don't have any temperature swings.
How nice
as we're
is that?
Bringing
Isn't
it up
it?
from vacuum, so probably from a very cold temperature
I mean,
up to
yeah.
about 72 degrees that they have in their cabin
they
temperature
can
on board
check
the
everything.
station, and then we'll get the hatches
That's
open.
good. It's like sitting on your PC.
Dragon SpaceX, hard capture complete. Stand by for docking completion.
Yeah, here we go.
Now that hard capture is complete, so that's confirmation of those 12 latches to create that airtight seal. Now that's complete, the umbilicals from the station side will interface with the Dragon vehicle umbilicals, and that'll provide power and communications through space station directly to Dragon. Pretty much the whole way up, Dragon's been using a combination of batteries and its solar cells pointed at the sun to make sure that it has enough electrical power for the journey up.
And this is just the beginning. This is just the beginning. Much more will come. You will see. But I like that. I mean, look how they control and get the information and manage.
Transmitting data through RF radio frequency on the way uphill. And during the final approach, this will give a hard mate, basically a wired LAN connection between the Dragon spacecraft and the International Space Station itself, and then also being able to draw power from the station systems using those great big solar arrays that are used to generate all of the electricity for systems on board the station.
Ladies and gentlemen, look at this view. Isn't that nice? They are in front of screens, touch screens. Get all the information, all the data. Can control and honestly. I like that. Simple and easy. Somehow, you know?
The soft capture system has been stowed. We see the umbilical starting to deploy. About 40% of the way so far, going pretty quickly. Should just take a couple more seconds until we're all the way connected. And then we should be getting that docking complete call out from the core here in Mission Control, SpaceX and Hawthorne. Standing by.
Yeah.
Dragon.
I think Mr. Musk would just laugh because he knows it works perfectly, right? But it needs high performance precision, you know.
Endeavor since the last time the United States spaceship had docked with the International Space Station. We have to congratulate the men and women of SpaceX at Hawthorne, McGregor, and at Kennedy Space Center. Their incredible efforts over the last several years to make this possible cannot go overstated. I'd also like to thank Kathy Leaders and her team of the Commercial Crew Program of NASA. An outstanding job by everyone. Last, I'd like to thank the men and women of the National Aeronautics and Space Agency. This is an incredible time to be at NASA. Again, and congratulate you.
Dragon arriving. Crew of Expedition 63 is honored to welcome Dragon and the Commercial Crew Program to welcome aboard the International Space Station. Bob and Doug, glad to have you as part of the crew. Well done. Bravo Zulu.
Hello, Kathy. Thank you, Chris.
Thank you, Chris.
Endeavour, this is Houston. Bob and Doug, welcome to the International Space Station after your spectacular rendezvous and docking of the first Crew Dragon vehicle. For the first time since the retirement of the Space Shuttle, you have completed a historic ride to the ISS and have opened up a new chapter in human space exploration. On behalf of the flight control teams here in Houston and in Hawthorne, California, and to our SpaceX colleagues, bravo on a magnificent moment in spaceflight history and on the start of a new journey that has changed the face of space travel in this new era of space transportation. Bob and Doug, good luck, and we look forward to working with you on board.
Who've been part of ushering in this new era of human spaceflight. On behalf of the SpaceX and NASA partnership, congratulations on a phenomenal accomplishment and welcome to the International Space Station.
Well, thank you, Anna. We appreciate all the good words and everyone thanking us, but it truly was, again, to our nation. Thanks for everything. Happy to be aboard.
And Dragon SpaceX, with that, ground figuring your video to go external shortly. And we have one request for Bob's suit doffing when you're ready to copy.
We copy all. Go ahead for Bob's suit.
During your approach suit leak check, we noticed Bob's suit pass with a lower PSID than his previous vehicle and O&C checks. We still had plenty of margin to support you in a depress, but in order to rule out potential hardware issues, when Bob is doffing, after he opens his structural zipper, check all 3 bladder zipper heads to see if any are partially closed. It is possible that if the head is backed off slightly, that the white tooth is partially visible or a small gap can be seen between the end of the zipper head and the gasket end. Please report observations. Great, thank you so much.
Wow. So now Dragon has completed its docking sequence. There's a number of checks. That was an absolutely historic moment. And in spite of that, the ground team's getting right back to business, talking about the suit performance.
Just let us know when the interior cameras are secure.
On Dragon.
To be able to do. While we're waiting for those tasks to happen, we're actually going to take a short break. But if in case you just missed it, the Dragon spacecraft are at the space station.
Yeah, they're there. It was just under a 19-hour journey from their launch to their docking, so pretty much right on what we were expecting. They got there a little bit early today, which was nice, as they were able to get through all those burns. But they're docked. It's going to be a little while. They have to do that vestibule pressurization, and then they'll have to do some leak checks.
Dragon on white teeth visible on both sides. It looks like a full white tooth. I'll give you an update once I get to the leg zipper.
Copy. White teeth on both sides, and we'll await your next status.
So the crew right now just going through some checks of their gloves. They're about to get out of their suits. That'll be the first step for the mission, putting it into that vestibule. And then once we get all the leak checks done, things are thermally stabilized, it'll be time for hatch opening. We'll be able to see Bob and Doug get into the space station for the first time from on board the Dragon spacecraft. And again, for Doug Hurley, this is the exact port he was at almost 9 years ago when he was on the very last space shuttle mission. And now he's commanding the first commercial vehicle to dock with the International Space Station. I think that we can't wait to see these crew members on board the International Space Station. Thank you for everybody who tuned in. We hope you enjoyed the launch. We hope you enjoyed the ride uphill. We really hope you were with us every single moment from suit up until now, so you've been up for over 24 hours. But it's been an incredible experience for us to see these guys get on board the International Space Station, to watch Dragon go through the paces, to be lofted into orbit on Falcon 9. Something we've been waiting for years, seeing it come to fruition. I'm still grappling with.
Dragon, SpaceX on Dragon
really
to ground.
Incredible.
Video is
and
no
Shiv,
interior.
It was an honor doing this with you today.
Yeah, absolutely, Dan. They
Dragon copies. Thanks, Anna.
can't step on the crew. That's the one rule.
Yeah.
The moon here at SpaceX for this. Bob and Doug have got to be excited, and now back to business to get the vestibule ready to go, and then get them on board the station. So again, thank you for following us. Please continue to watch as Gary takes over for the hatch opening portion, and keep following our social media for more updates on what's happening with hatch open.
Over to you, Gary.
Thank you, Shiva. Thank you, Dan. What an incredible flight for Bob and Doug, lifting off just yesterday and now in space, attached to the International Space Station. Some kind words all over after docking at 9:16 a.m. Central, and a hard mate just 11 minutes later. We're still not done here. We're going to take you through the pressurization sequence and eventually hatch opening
SpaceX
of the
Dragon
International
on
Space
Dragon to
Station.
ground. Cabin mic check, com.
And I hear you loud and clear on Dragon to ground. How many?
Loud and clear.
Excellent.
Good comm checks. We're still...
And SpaceX Dragon with an update from Bob. It looks like a white tooth on the leg zipper as well. We'll take a close look if we can see anything else that might have resulted in that lower leak check pressure.
Copy. Really appreciate the report. Thank you.
Teams behind me will be configuring the Dragon and the International Space Station to welcome Bob and Doug aboard. First, of course, the International Space Station attitude control moment gyros, really holding the Dragon in place through the hard capture sequence. We'll start enabling those thrusters and pressurizing the vestibule. It'll take about an hour until we're able to get the aboard the International Space Station. Commander Chris Cassidy standing by in Node 2. Right in front of that is the pressurized mating adapter. He recently opened up the hatch to introduce some of the station air and mix it, get a nice mix in there, avoiding some CO2 pockets. That hatch you see just beyond Chris Cassidy there is normally closed. He was able to open it a little bit earlier today, mix some of that cabin air, and get rid of those CO2 pockets, make sure it's all clean and ready for Bob and Doug. He closed it shortly after just to make sure no FOD or foreign objects, anything were to float in there that would inhibit any hatch opening process today. One of the next milestones for Chris Cassidy will be to open up that hatch. He's got some cameras you see placed within that node. We'll get some good views of the hatch opening and welcoming Bob and Doug here in just about an hour. A big moment in history today, May 31st, 2020. Just on the other side of that hatch, Bob Behnken and Doug Hurley have successfully arrived at the International Space Station. Still a couple of milestones to get through. Before we can open up that hatch, it's going to take some time. First, pressurizing the vestibule in between the station and Dragon. We'll bring that up to pressure. It's going to take some time for that pressure to stabilize. Of course, the temperature within that vestibule causes a little bit of swing, so we'll just wait for that to pressurize or to stabilize before opening up that hatch. Here in Mission Control Houston, Flight Director Zeb Scoville welcoming the director of the NASA Johnson Space Center, Mark Geyer. We'll have a few other VIPs here in the room to welcome Bob and Doug once they get through that hatch. Now again, this
we have a blue
repressurization
screen
and hatch opening process is going to take some time.
Here we are back.
You see now we're going to have some intermittent losses with the communication from the International Space Station. You're seeing now the International Space Station Flight Control Room led by Flight Director Zeb Scoville. Just a handover of some of those audio and visual communications. We'll be regaining those shortly. Might lose them intermittently throughout the repressurization process, but the teams here will be monitoring all of the procedures, again, pressurizing that vestibule and eventually getting to that hatch opening. From right to left there, seated, you see Flight Director Zeb Scoville. It was he who was leading the teams for both the launch of Bob and Doug over at the Cape. He was leading the teams here in Mission Control Houston. You just saw the Johnson Space Center Director Mark Geyer walk off to the side. Seated next to Zeb Scoville, Joshua Kutrick. He is one of the members of the most recent class of astronauts, the class of 2017. Canadian Space Agency astronaut, went through candidate training and officially became an astronaut just recently. Again, a few milestones to get through to that hatch opening. First, the International Space Station attitude control has been successfully switched from control moment gyro only control, enabling some of the thrusters on the International Space Station. We also just received word that Dragon is successfully receiving power.
Ground ISS power connection has been established.
And there you have it. Dragon is successfully receiving power from the International Space Station.
And Dragon copies on Dragon to ground that power has been established. Just let us know when we should make a hardline comm check.
We will, Co. Thank you.
For those of you just joining us, you are getting a live look at NASA astronaut Chris Cassidy, commander of the International Space Station, doing some of the prep work to open up the hatch and get ready to welcome Bob Behnken and Doug Hurley aboard the International Space Station. They launched successfully yesterday at 2:22 p.m. Central Time, 3:22 p.m. Eastern, and docked successfully with a contact and capture just a little bit ago at 9:16 a.m. Central Time, 10:16 Eastern. Now, some of the milestones to get that hatch open have already taken place. First, attitude control. For some of the docking sequence, for the initial contact and capture, attitude control was on Russian thrusters. That was moved to control moment gyros for hard mate, making sure that everything lined up and we got those ready-to-hook indicators green before driving those hooks. The attitude control has since been switched to enable